In this video, we're going to look at sample size determination, and we're going to find the sample size needed to have a confidence interval with a certain amount of margin of error and a specified confidence interval percentage. So in this question, we have a Reader's Digest Gallup survey on the drinking habits of Americans estimated the percentage of adults across the country who drink beer, wine, or hard liquor at least occasionally. Of 1,516 adults interviewed, 985 said that they drank. And we want to determine the sample size needed to ensure the margin of error will be at most 0.02 for a 95% confidence interval. And they do give us specified formulas for this. And since we have a proportion, it would be N is equal to Z over E, which is our margin of error, all squared, P times 1 minus P. So if you have this formula given to you or you remember it, that's great. Or you can remember that margin of error is the right side of our confidence interval formula. So we have Z alpha over 2 times the square root of P times 1 minus P, all divided by N, is equal to margin of error. So you could use either formula. This first formula is nice because it's solved for N, so it's a little bit easier to use. But you could also use this other formula if you didn't remember the formula that's solved for N, and plug everything in and then solve for N. So in this case, we know that P is equal to 985 divided by 1516, which is equal to 0.65. And then Z alpha over 2 is equal to, now we have a 95% confidence interval, so we go to our table and we see 95% confidence interval, Z is 1.960. So we go back to our problem and it's 1.960. And now we plug all our numbers in. So we have N is equal to 1.96 divided by E, which they want to be at most 0.02, squared times 0.65 times 1 minus 0.65. And when we calculate this, we get 2,184.91. And we always round up, so we need a sample size of 2,185. In our next example, we have, in a 1903 paper, Abigail Camp Diamond discussed the effect of environment on the shape and form of the two sea snail species. One of the variables that Diamond considered was length of the shell. She found that the mean shell length of 461 randomly selected specimens to be 11.9 millimeters. And we want to determine the sample size that would ensure a margin of error of at most 0.1 for a 90% confidence interval. And our formula is N is equal to Z times sigma divided by E squared. And again, we could get this by having Z alpha over 2 times sigma over the square root of N is equal to E, and then solve for N after we plugged everything in. So in this case, they gave us sigma, and we know N. So the only thing that we need to look up is Z alpha over 2. And we're doing a 90% confidence interval. So we go to our table, 90% confidence interval to Z, 1.645. So Z alpha over 2 is equal to 1.645. So N is equal to 1.645 times sigma which they told us is 11.9, divided by margin of error, which is 0.1, and all of this squared. And when we calculate this, we get 1,691.266. So we would need a sample of 1,692 to have a margin of error of at most 0.1 for a 90% confidence interval. And that's our video on sample size determination.